Hi, welcome to College Algebra 5.1, talking about exponential functions and their graphs. So, what's an exponential function? An exponential function simply has an exponent. I will refer to a as the base, so this right here, and of course x in this case as the exponent. Importantly, a should be greater than 0 and non-equal to 1, because 1 to the power of anything is pretty much always 1, and it's not very interesting. The reason we have a is greater than 0 is we want a to be a positive number because the negative out front is actually a transformation, so we keep track of just the individual number to start. So for example, 3 would be my base, to the power of x, I could do g of x, and if I do g of 2, remember, I'm just replacing x with 2 and plugging it into that exponent. Here, same idea. Now, I am dividing right here because 1/2 is what has the exponent, so each of the 1 and the 2 get the -2 for an exponent. Remember that when I have negative exponents, they get flipped. So top things go to the bottom things go to the top. So 2 squared would be 4, 1 squared would be 1, so 4 over 1, that's how we get 4 right there. Okay. Graphs exponential functions, there's usually growth. It's growth if the base is bigger than 1 and the exponent is positive. So for example, something like 3 to the x as we just showed, that would be a growth function. Or when the base is between 0, 1 and the exponent is negative. So just like we had earlier, this idea of 1/2 to a negative x. It's decaying when the base between 0 and 1 and the exponent is positive. So, 1/2 to the positive x. Or the base is bigger than 1 and the exponent is negative. So 3 to the negative x. So just some slight tweaks here. Now, what does growth mean? Growth means it is always increasing from left to right. I am always increasing. So that would be a growth. Just like over here, I'm always increasing, so that's growth. Decay means it's always decreasing from left to right. So as you see, my graph is constantly going down. So I'm going to be decaying. You also might notice that both of these have a horizontal asymptote. That is actually really important. So you get this horizontal asymptote at y equals 0 for these. But let's actually talk about more about these things, these graphs. Well, the domain. Remember, domain are my x values. Well, I can go left forever. I can go right forever, which means my domain is unbounded. I actually have negative infinity to positive infinity. Remember, you can also express that as the double R. As for my range, remember my range is my y values. And we just talked about how this graph has this y asymptote at y equals 0. So I would go up forever. So I go all the way to positive infinity vertically. However, the furthest down I go is 0. So I would have a range of 0 to infinity. X-intercepts and y-intercepts, well, because I never quite get to y equals 0, I have no x-intercepts. I do, importantly, have a y-intercept. It uses this idea here. Well, remember that a y-intercept always has an x value of 0. So I can plug 0 into my equation, so 3 to the power of 0 would give me 1. In fact, this identity is really important. This idea that anything to the power of 0 exponentially gives me 1. So more often than not, my y-intercept is often 0, 1, as we see right there. We can see that this is a growth function for a couple of reasons. One, I can see the graph. Also, I have a base number bigger than 1 and a positive exponent. So I know I am increasing always. So my increasing would be from negative infinity to positive infinity. Remember that when we talk about increasing and decreasing, as I said earlier, we're talking about left and right. Well, what values run left and right? Those are our x values. So I frame those in terms of x values. If I'm always increasing, I am never decreasing there. Horizontal asymptotes we discussed was y equals 0, and I have no vertical asymptotes. If I were to repeat the process for this problem right here, my domain stays the same, my range stays the same, my intercepts stay the same. The only thing that's different is increasing and decreasing. I am never increasing here, and I am always decreasing. Okay. Transformations. Recall that transformations are changes in a base function. So if something ever happens on what's called the inside, that is horizontal. And recall horizontal are our x values because x is going side to side. If it's ever on the outside, it's vertical. And vertical are always our y values. And I say that inside versus outside back when we talk about transformations. Here in the context of this, because these are exponential functions, inside I just mean inside the exponent. Outside, outside the exponent. So this is our base function right here, 3 to the power of x. Well, if I were to compare that to 3 to the power of x minus 2, I see I have this minus 2 inside the exponent. That minus 2 is up in that exponent. So I know this has to be a horizontal change. Now, horizontal is functionally always opposite. So this minus 2 is actually going to shift my entire graph right 2 units. Now, what's that do? Well, let's say I have a really nice coordinate, such as 0, 1. Well, I'm shifting the entire graph right 2 units, which is affecting the x value. So instead of having this coordinate of 0, 1, I'm now going to plot the coordinate 2, 1, because I shifted my x value 2 to the right. So I can plot 2, 1. I have no other changes, which means the asymptote stays the same, the shape and structure stays the same. So all I need to do now is redraw my asymptote, y equals 0, and the rest of my graph. Okay. This next one, I see this minus 2, and this is outside of the exponent. So this is vertical, so it's going to be up and down. And minus 2 is down 2. So instead of having the coordinate 0, 1, well, again, down is affecting my y value. So my x value is going to stay the same. Instead of it being at 1, though, because I'm going down 2, I'm now going to have 0, negative 1 as a coordinate that I could plot. But everything else stays the same. Except I have to recognize my original horizontal asymptote was y equals 0. But I'm bringing everything down 2. So now it's going to be y equals negative 2 right here. So my asymptote gets shoved down as well. And then I can graph and finish the rest of the picture. Again, that shape stays relatively the same. Here, I have what I was talking about earlier. I have this negative out front. So whenever you're multiplying by a negative, that is always a reflection. Now, this negative is outside of the exponent. What I mean by that is if I look back a slide, here this negative was on the inside of the exponent. So what it did, if you look at these graphs, is it reflected this original right here across the y-axis. So here, multiplying on the outside, again, is vertical, so it's going to be a reflection across the x-axis. So instead of having the coordinate 0, 1, this 1 gets multiplied by a negative, so it becomes 0, -1 gets plotted. My asymptote actually stays the same, so I get y equals 0. But now, my shape, everything gets swapped down here. Interestingly enough, this actually does mess with my range, because my range is no longer 0 to infinity. It would be -infinity to 0, because again, range is the y values that I get. I never cross that asymptote in this case. Okay. Next. E follows the exact same rules functionally. The big thing is if the exponent is positive, it's growth. If it's negative, it is decay. Everything else functionally is the same thing. E is just a number, and it's actually on our calculator. It is second ln, I believe, on the left-hand side. Okay. Interest problem. If you ever hear continuously, you have to use this formula. If you ever hear something like 12 times per year or something like that, where you're told how many times it compounded, I would use this one right here. The big thing is n is number of compounds per year. So if you heard monthly, it would be 12. If you heard daily, it would be 365. If you heard weekly, it would be 52, etc. Stuff like that. P principal is how much you invest. It's also how much you start with. Rate, you have to convert that into a decimal. It's a big deal. And A is how much you end with. Nice thing is all those are used over again. T is number of years. Thank you for listening, and I hope you have a great day.